Welcome to Data Science with EJD. This is the last video talking about deployment and monitoring of machine learning projects or machine learning models, if you like. So here, the focus is on model monitoring and retraining. Model monitoring and retraining. So after you have a model that's working, you deploy it. You don't just leave it and go away like that. You have to keep monitoring the model to see how it's performing. And once it stops performing according to what you like, may have to retrain. That's why this video is important. Monitoring and retraining. The motivation is this, that machine learning models degrade over time due to data distribution shift. Maybe as more data is added to whatever you're doing, so there can be a kind of shift. So you have data distribution shift, behavioral or market changes, label changes, emergence of new patterns. So once any of this happens, you'll be motivated. You will have to actually, do something about it. So a system is needed. So you need a system in place to detect, visualize, and respond to these changes quickly. And that takes us to drift types and recap. So drift is basically about the kind of changes that occur to your model, to your deployed model, so to speak. So let's look at drift type. You can have a data drift where the input, which occurs due to changes in your input data distribution. An example is average age of users gets to increase. So you may have to do something about that. You can have a concept drift like a future target relationship. So for instance, you have same transaction pattern leading to new fraud rules, right? Then you can have a label drift where you have a change in output distribution. And then in that case, you have to, an example of that is like a positive sentiment ratio declines. Then another drift type will be feature importance drift. And what changes here is whether you have what changes is predictive power of features, changes. And in that case, a very good example will be like a feature loses relevance over time. We did something about feature importance, and I think random forest is particular. Is it random forest? Yeah, I think random forest is particularly good for to help you. Or I think the first time we talked about feature importance was when we're dealing with lasso regression. It collapses any feature that is not so important to zero, so you can see the ones that really matter. So when feature importance changes, that means that some features that were important at the point of training the model lose their relevance, and you have to do something about. You now have to, maybe some new features have to be paid attention to. Okay, those are some types of drift that can occur. Then you can have. Let's talk about monitoring plan overview, especially with a dashboard. For instance, you need a visualization to like Streamlit dashboard. With live PSI accuracy. In a minute, you'll understand what PSI is about. Or maybe we should get it at once. PSI. Have I talked about PSI somewhere? PSI. Um, so it's an indicator of how well the model is performing. Okay. Yeah, if we don't have it here, let's go search for it. PSI, PSI in machine learning. In machine learning. Okay, we have it here. Okay. So that's population stability index. In the context of machine learning, PSI stands for population stability index. It's a metric used to monitor the stability of a machine learning model by comparing the distribution of input features or target variables in the training data sets with the distribution in newer production data. By measuring the difference between these distributions, PSI helps identify potential data drift, which can indicate that the model's performance may be degrading. So that PSI is population stability index. So it helps us to know if there's a drift, especially data drift in a model. All right. So monitoring plan overview now with a dashboard, for instance, you need a visualization tool like a Streamlit dashboard, where you can have live population stability index, then accuracy and even alerts. Then you have frequency like daily collection or weekly analysis. You need metrics tracks like the PSI, KS test, prediction accuracy, class distribution. Then you need trigger conditions like, oh, once the PSI is greater than 0.2 or accuracy drop is greater than 5%, then it will trigger the system to tell you not something is wrong with the model. And then you also need to talk about the retraining type, which on a drift or performance drop, you need to do that. Then retraining data, like you need a rolling window, which is last 30 days. So you need to retrain like after every 30 days or something like that. Validation, you may have to do an A/B testing plus offline metrics. And talking about deployment, maybe you need a canary rollout via CI/CD pipeline. Okay, then let's talk about the Streamlit dashboard design. The components will be things like sidebar filters. So you have to choose feature, data range, and model version. Then you also have the main panels. You have a drift detection table with PSI/KS values per feature. You need performance over timeline chart. You need confusion matrix and ROC curve. You also need alert summary if drift or accuracy threshold is violated. You need alert summary. Okay, so this takes us to a dashboard code for this kind of situation using Streamlit. So this gives us a basic prototype. Of course, since Streamlit is the focus here, you need to import Streamlit as ST. ST is the alias here. Then import pandas as PD as usual, NumPy as NP, Matplotlib as PLT. Then you get all your metrics, accuracy score, confusion matrix, ROC curve, and AUC. Then you need to visualize using Seaborn. Then you have all the scikit-learn, functions like train test split, logistic regression, and label encoder. And here now, you are setting the title to ML, machine learning model monitoring dashboard. That's what this is about. So here you load a well-known data set, like Titanic data set from Seaborn. Okay, we already have Seaborn up there. We don't have to worry about it anymore. So from Seaborn, you can load the Titanic data set. Okay, so here we have data to be SNS.load dataset. You know, load dataset is a function inside of Seaborn, and Seaborn has been imported as SNS. So load dataset Titanic, and then you're dropping the age, the fare, the sex, the class, and survived because we don't necessarily need those because you're doing a logistic. Oh, okay, well we can actually use them, but we just don't need them. So we are doing a logistic regression. So we have data sex that's label and with a label encoder. So you have fit transform data, the sex data you're transforming using the label encoder. The same you're doing for class. Okay, so then as use age as the feature for the drift detection. So feature is age now. All right. So you want to now split. So since you're using age, so if something goes wrong with the age, it helps you to know that you need to that there's a drift already. So you can split into train and production like data sets. So simulate distribution drift. So train DF, pro DF, train test split, data test size is 0.5. So you're taking 50% as test size and 50% as trained size. So, and of course, random state is to ensure reproducibility. Then you can now train a simple model on train DF. So you have X train is train DF feature, talking about the age. Now, Y train is train DF survived. So who survived according to age? That's the kind of thing we are looking at here. The model is logistic regression. Then you train the model in line 32, and then production features and predictions. So you now have X prod F feature, Y prod DF survived, and ypred is modepred xprod like that. Then you create predictions log data frame. So prediction data frame, you have pd.data frame true yprod ypred like that. So then the sidebar feature for select doors, only one feature here, but kept for demo. So you put that. Now we are not going to get the actual dashboard here because I'm not doing the whole Streamlit thing, but I'm going to provide a Jupyter Notebook version that shows you at least a bit of what you're going to see in the full dashboard, right? So the PSI calculation function comes there. So you define the calculate PSI, expected actual buckets. This helps to calculate the population stability index, which helps you to know if there's already a data drift in your machine learning model. So it can trigger something that helps you to know you need to update your model or you need to retrain your model. And the PSI calculate PSI train DF feature by prod DF feature. So estimetric helps you to do the PSI for feature and gives it to you in 3 decimal places. So then the drift status will now be like if PSI is greater than 0.2, then ST1 so it's just tell you drift detected. Else it will tell you no significant drift, right? So you have model performance metrics. So the true labels will predicted data frame true. Paired labels predict the data frame paired also. So accuracy, you have the accuracy score for true labels and predicted labels. Then S3 metric it tells you about the model accuracy. Then you do a confusion matrix as you usually do, and you also do an ROC curve. So if you run this, it doesn't tell you so much, because okay, I mean, it's taking a bit of time to run through all the process, but by the time it's all done, you don't get to see so much because it's going to be based on the Streamlit, and so you need to run it since it's more like a dot py thing, which I'm not doing right now. So, but I mean, if you do a Jupyter Notebook version, so we replace all the Streamlit stuff with the possibility of printing or producing the graphics. So instead of doing all this pipe plot, fig rock, and all the rest, then you now do so you do a normal Jupyter notebook thing. So the kind of thing you're going to see in that situation. So you can see this does not involve Streamlit anymore, but it gives you an idea of what you're going to get from up there, which you have not got there. So I run this now, and then you can see some interesting. Uh, okay. Oh, I haven't run it. Okay. Okay, I think I ran this the second time. So I should come here now. So it's basically the same except that I'm not using Streamlit anymore. This one is just it's Jupyter Notebook friendly. Now you see ML model monitoring dashboard. So tells you monitoring feature is age, right? Then PSI for age is 0.00. And when you get 0.00, it tells you no significant drifts. The model accuracy is 61.34%. Okay, so and then we have this kind of thing. I think this is the what is it called now? Confusion matrix, right? So we have this, and then we have the ROC receiver operating characteristic. That is ROC. So you have true positive on the vertical axis and false positive on the horizontal axis, and you have something like this. So the AUC is 0.54. So you have those metrics like that. So I mean, I think this is the same as what you have at the top, right? Same here. And then this more like a repetition. So for the confusion matrix, this is what you have. So then you can also automate retraining. Okay, I think we have two things. This is receiver operating characteristic down here, and this is confusion matrix. Okay, so we have okay, it's like it's done in triplicates. We don't necessarily need this. We can do it in such a way that we just have the only one we need. Okay, but so this is not the dashboard itself, right? But this is what the dashboard is going to look like when you do it in Streamlit. Okay, maybe at some point I will go full-fledged Streamlit and do and show the whole thing. So automating retraining based on dashboard metrics. So you can also automate. We're talking about model monitoring and retraining. So if something goes wrong with the model, so you can also retrain. You can automate the process of retraining. So you can monitor and retrain, right? So you can use the Python function which you call monitor and trigger retrain. So PSI scores, you have the column calculate PSI, train df call, production. So you have the train and the production, right? That's more like the reality. So for column in production columns, right? If any score, the PSI score is greater than 0.2 for score in PSI score values, or accuracy score is less than 0.9. So you have set the limit like that. Score greater than 0.2 and accuracy less than 0.9. So you can now print trigger retraining. Then you now retrain the model and validate and deploy model. Else, it's just a model is healthy, no retraining required. So when you run this now, it will evaluate the situation and then it won't say anything. So in this case now, it doesn't print model healthy, no retraining needed. So it means that the retraining has been done, based on what the situation looks like. So if I run it again, okay, it just does the same thing. I run it again. So it keeps retraining each time. So let me keep trying as many times as possible and see if I'm going to ever get model retrain healthy not. So the retraining is still ongoing like that. Okay. Yeah. So the model keeps getting retrained because I think the accuracy score that we've been seeing is like 0.5 or something like that. So here you can use Airflow or Prefect to run this on a schedule, e.g. every Monday at 7 a.m. So in a normal place when you're deploying this, you need to use some extra things. But it's just like a kind of introduction to what is possible. So let us look at a deployment architecture. So you need the model registry, ML flow, machine learning flow, monitoring dashboard. You need Streamlit, which is deployed via Heroku or EC2, which I mean, I don't have all that facility right now, or I'm not interested in going that far right now. Then you have the scheduler, which is Apache Airflow, drift checks plus retraining tasks. Then login, prediction sent to log store. That's PostgreSQL or S3. Deployment, you have Docker plus CI/CD in so GitHub Actions and Jenkins. So these are like some things I'm not interested in right now. Then 27, example retraining trigger flow. So new production data logged daily. So that all those DF prod you're seeing, that's the new production and the data associated with it coming into the system like that. And as those are coming, they can trigger new things, right? So we have all that. So Streamlit dashboard reflects updated drift and performance stats. Then Airflow DAG checks the population stability index and accuracy weekly. If thresholds are violated, new training data is collected, model is retrained and validated, version is logged in MLflow, and canary deployment to the production. So future enhancements, you can add real-time prediction logging with Kafka or PUB/SUB. You can include explainability drift via SHAP in Streamlit. You can integrate online learning models for streaming scenarios, and you can add alert notifications. Maybe using Slack or PagerDuty. So of course, I've not gone full deeply into all these other things needed, but I mean, you can. So for this can serve as a starting point for people who want to use Streamlit for monitoring and retraining. So with this, I come to the end of this video. If you need if you let me know how helpful this is for you, and if there's something you'd like me to try out, feel free to let me know. If you have subscribed to the channel, thank you so much for doing that. If you have not, please go ahead and subscribe and hit the notification bell so you can always get alerted each time a new video is released. On my channel, you can become a member and you feel free to click on join to see the possible membership level you can join and the perks associated with them. You will really love them. And if all you do is subscribe, of course, you still have your videos coming like that. Okay. Right. So be sure to like and share also so that more people can have access to this great content I have going on here. Till I come your way again, keep doing data right. Bye.